Hi everyone. This is a review, NET-136 OS2, weeks 1 through 3. The course is a little bit unique this year. We're meeting on Fridays, and it's every Friday, 8 to 11. So we have the 3-hour span. We have a couple different areas. We talk about the theory of the class. A lot of that's done in class. We're going to talk about the theory behind operating systems, basically what they do, and in here there are some terms that the student will need to hear and go through and be able to tie to operating systems. We cover skills, and the skills we're going to cover Linux, and we approach that a couple different ways. Okay, there's online curriculum for that skills and takes you to a certain level of testing for Linux if you want to get certified. And then we have in-class skills. They go beyond the online with a lot of how you would manage a Linux system. Everything from the install to managing users and applying packages. What I mean there, packages, or the idea of being able to set up some servers, which could be, more online. So the class talks a lot about open systems. And we're using Linux as an example, but we install Apache and MySQL and so forth, these servers. We don't install all the servers you could install on Linux, but getting those two key ones, Apache for web services and then database services with MySQL. You see those two, you should be able to move on to other types. Most of the materials are online, and we actually use NetIACC for the materials. We started talking about computer systems. You have software, hardware, obviously people, and then a way to communicate. Alright, so let's move on to the next page. We talked about installing an operating system, and the key thing when you're going to install it, what's the purpose? Are you going to install for a workstation? You're going to install for a server? How are you going to install? You're going to use a flash drive from a live flash drive. Somewheres you have to determine what you're going to use the system for. And in here we just talked about these two fundamentals. Are you just going to use it as a server with lots of people accessing the information, or are you going to use it actually as a workstation? Okay. There are a lot of people in the world that have installed Linux and they use it as their workstation. We talked a little bit about the plus and minuses to Linux versus other operating systems. Linux, what applications you're going to install. Okay, first of all, what distribution of Linux, and we're going to do Fedora. People have talked about Mint, Ubuntu, and so forth. So you have the different distributions you can install. We'll talk about what applications you're going to install with the certain distribution, what apps are you actually going to have to use. And we went down, we talked about the OS in general, and then we talked about the swap file. The system, if you have this being memory, you can put virtual memory on the hard drive. It's referred to as a swap file, often called a page file. It's a contiguous space on the hard drive that can be treated as memory. Okay, so when you don't have enough room in memory, the computer can use that to access the information. So a lot of systems will set up the swap file automatically for you. If you want to do that, they usually make this the size here for the virtual memory 2 times however much memory the computer currently has. We talked about partitions. You know, are you going to put all your apps out on a partition? You know, how are you going to organize the hard drive? That, you know, how you're going to do that if you're going to divide it up and so forth. Okay. During the install, we're going to record all the passwords and then make them available to the instructor. So I emphasize, you want to use in-class passwords that you're not using anywhere else in the world. We're using a private address, IP range, that 150, and this is the default gateway, and this is for the servers in the room. Individually, the students are going to use virtual machines to install their information. So we did the install, hard drive, we reviewed kill disk, number of things, and so while you're doing the install, you're going to record all this information, you're going to set the root password, you're going to set up a user as an administrator, and so forth. We did it similar on the servers, and then they did their individual virtual machines. Background, boot process, basic skills. This is a side note. We talked about learning. We talked about learning and grit, and we still need to watch the video talking about not being afraid to fail in class. School is a great opportunity to some failures and move on. I'll go through this very quick. We talked about some fundamental things from computers. We talked about 32 and 64-bit. We talked about Intel. We reviewed the process. We talked about software, system software, and applications. The OS is what we're emphasizing in this class, but there's also utilities we'll talk about. Terminology, so we're all using the same thing. We have the processor, we have memory, and I'm going to refer to storage as storage. Some people call that secondary memory. People should be able to use technology. What we want to be are experts, and then I talk about, you know, everybody starts at a different level, especially when it comes to Linux. You know, we have some people that have used it a lot, and we have some people that have never used it at all. The key is where do you want to go from where you're at. Okay? And we'll talk about networks. I like this diagram. You can think of hardware in the middle, and the operating system communicates with the hardware. You have some user interface, or you have some type of shell that the user interacts with. Then you have an app, communicates with the operating system, and the user communicates with the app. Very typical way to design or think about technology. Okay? And then all those things the operating system has to do with the hardware. Manage memory, processor, scheduling, storage, interrupts, traps, and so forth. Okay. This is the third day. So this would have been Friday, and that would have been 2/5/16. And we went through basic commands. Students now need to be organizing their engineering journal. We've had a lot of lead-up information, and now they need to start recording the actual commands. We talked a lot about the GUI today, and we have a whole lab in which they use their virtual machines to access things via the GUI, the user interface. We talked a little bit about theory today, and that's at the end of this. And we talked about where they're going in the curriculum. Chapters 3 and 4 next week, 5 and 6 the week after that. So that's double the workload than what it was, so they'll be busy. In-class engineering journal. They should have how to log in, install basics, you should know those, you should be able to access both servers, and do some basic commands. And we went through a lot of basics commands today. So we logged into the first work server, and then we first start out talking about file structures. We talked about environmental variables. We looked at all of them right here, this command for environmental variables, and we looked at the tree, and the tree allowed us to see that file structure. Okay, so let me re-emphasize this. These are the actual commands. So what a student would do, they need to record these and indicate what they do. Okay? And however way they can do. Next thing was change directories. Absolute and relative. The absolute path, you can give a slash and give the entire path to the directory, starting at the very top. Relative, you can just indicate where you're going based on where you're at. If you're not sure where you're at, this command right here, pwd, will give you your present working directory. Okay? So let's take a look at these. This will change directory. There's a space there. That'll take you back all the way up to the very top of the hierarchy. Some people refer to that as the root of the tree, however you might want to term that. Takes you to the top of the hierarchy. 2 dots, there's a space there. 2 dots will move you up 1, take you to home directory, home directory, home directory, and that's home directory. That home directory is home of the current user, you know, whoever you are logged in. Okay, lets you know where you're at. And then here's an example of a path. Variable directory, that slash starts us at the top of the hierarchy, then go to the library, and then there's a directory called mlocate. And that actually works with this locate command. So let's go down the list. This will give a listing. It will show list contents. This will show you the list of files and directories you're currently looking at. Right here, wherever you're at. This is a long listing. Okay, let me see here now. Yep, so this is a long listing. That's actually an alias. Here's a list. It'll show all the files so you can see the hidden ones. Here's a list. It makes it a long listing with all the files. This is a recursive, that capital R, recursive, and it shows a listing of files and then all the directories that fall under that. All of that be relative of wherever you're at. Okay. Find information. These deal with commands. You can do where is a command, find out where it's located. What is a command? This gives you this, the first line or two from the man. This is a manual. Tells you lots of information about a command. And this will, you can type in a topic, and this will give you where that topic appears so you can find information about that topic. Okay, again, where it is, what it is, first couple lines, and this will give you a complete breakdown of the command. The locate locates files, a little different than those up above. There's a database that keeps track of that. It updates usually every morning, and if you want to, you can update it if you're at root, if you have administrative rights. Okay? I'm going to keep moving. We use VI to create a file or edit a file. Once you get into VI and you give a file name, if it's a file that already exists, you'll see it. If it's a new file, it'll create the new file. And then if you hit the letter I or hit the insert key, it'll put you in insert mode, and then you can toggle into the replace mode. This is where we work a lot. You can use escape to get out of that mode. Once you get out of that mode, you can type a :W, and that will write the file to disk. You know, that'll, here it is in memory. You're working on it, and that'll write it to disk like a save. A Q is for quit, and this is a quit. That's an exclamation point. and that will quit without saving. Okay, so you have a file and you edit it and you decide you don't want to save it, you can use that. Okay, a lot of times after people work on a file and they're all done, they'll go WQ, so that will write and quit, and you'll exit the file. Touch will just create an empty file for you, so then you'd have an empty file. How to look at the file is you can type a less, and you have to use a Q to get out of that. Actually, you can use a small q too. More does something similar. You just type more in the name of the file, and it'll give you like a page at a time. And then you can use the space bar. You can use the space bar to move pages at a time, or you can use the enter key to move one line at a time. Okay? This is concatenation. This also will show you a file, but it'll list the entire file and go back to the prompt. These, when you quit them using a Q, you don't see them anymore. You go back to your prompt without seeing the file. Alright, now we've got all of these, and these are pretty straightforward, I hope. MV means move a file, and you'd have to give which file and where to go with it. So you'd have to give some type of path, which we talked about already. CP, copy a file. RM, remove a file. Make a directory, remove a directory. And in most cases, depending on how yours is set up, remove directory, the directory would have to be empty. Okay, I'm back here. Had a little detour there. You can pipe information. This is a vertical line. It's above the, usually above the enter key. You have to use the shift to get it. And this will take the output of whatever this command is and push it into it becomes the input of the next command. So this is a long listing, and we're going to pipe it into the less command. So the less command allows us to scroll through it. Okay? Piping. You'll learn a lot more about that as we go. You can type the word history, and that would give you all of the keystrokes you had. And it's like depending on how your system's set up, it might be 1,000 or more. Alright. Redirect your output. This will create a file. You can take the output from, it'll take whatever the output is from this command and put it right in that file. And this will take the output and append the file. It'll take whatever this output is and put it on the end of the file. So those were the first lead-up commands. Okay, so I think I'm okay here. The last thing we have here, we talked a little theory. Operating systems nowadays, they tend to be very modular. The kernel, which is the key to all operating systems, that's the code that makes it work, that's what's running everything. What they refer to as microkernel, they try to make that small and then have lots of modules work with that. So when you get a new USB standard, you know, the USB is a standard, but you get up to a new version, you can easily slip that module in without having to change the kernel. What does the kernel do? Execution of processes, schedules those processes, allocates all the memory, allocates secondary memory, storage, allocates access to peripheral devices. That might sound pretty simple, but that's a big chore. That's a big chore in a computer. We work in kernel mode, user mode. We're in user mode most of the time. A person is looking at an app, or an app is executing, doing its task. Then all of a sudden it needs to do something. A very simple one would be it needs to write something to disk, or it maybe needs to access the network. Something needs to go to the cloud somewheres. So we can have a system call. A person can generate, the computer can generate, and what we have then would be some type of an interrupt. sometimes referred to as a trap, and sometimes it's an exception. So in cases of what we cover here initially, software can have an interrupt, the hardware can have an interrupt or a trap. We'll detail that more later. Or an exception, something happened and causes an exception. Okay? So the system has to do something else. A really simple example would be if you have a big file and it's writing to the hard drive. You can be writing to the hard drive and the computer can be processing other things. When that write's done, you could get an interrupt, a hardware interrupt saying, I'm done doing that work, so the processor knows that's done. And then it can relay that to the app. Because the OS would write to the hard drive, right? Because that's one of its jobs. That's it for weeks 1 through 3 review.